In section 2.2, we're going to talk about circles. Now, what the definition of a circle is it's a set of points equidistant from a center. So I'm sure everyone here knows what a circle looks like. Here's a not so good circle. We have a center here. The center we use the coordinates HK for. And any coordinate on the circumference we'll use XY. And the distance that's the same, the equidistant, is called the radius. Now, the general format or standard form, or even sometimes books call it center radius form, is x minus h squared plus y minus k squared is equal to the radius squared. Now this actually comes from the distance formula. Remember, the distance formula says we take the square root of x1 minus x2 squared plus y1 minus y2 squared. Well, the distance is called the radius, and we're finding the distance between the center and a point on the exterior. So this would be x minus h squared plus y minus k squared inside of a square root, but that doesn't look pretty, so if we square both sides, we get x minus h squared plus y minus k squared equals the radius squared. So that's what we want our equations to be in. From here, we know that the center is h comma k, and our radius is equal to r units. Remember, this radius is a form of distance, so we always want to make sure that we say units whenever we're talking about distance. So I have four examples for us in this section. First one is, let's find center radius form if the center is -3, 4, and the radius is equal to 6 units. Okay, well, looking at our equation here, it's going to be x minus the h value, so x minus -3 squared plus y minus 4 squared is equal to the radius squared. I don't really want to say minus a negative, so let's just write x plus 3 squared plus y minus 4 squared, and we always just go ahead and square this, and that's 36. What if I asked you to graph the circle, whose equation was x plus 3 squared plus y squared is equal to, let's say 25. Well, in order to make this look like center radius form, it has to be x minus something, right? So this is really just x minus -3. And if the y is by itself, it's really just subtracting 0. 25 is 5 squared. Generally, when I'm doing these kind of problems, I always look to find the opposite of what's inside the parentheses. So if it says plus 3, the radius is going to be -3. If there's no other number in here, it's just 0. And we know that our radius would be 5 units. So prepare yourself for a terrible drawing of a circle. The center would be at -3, 0, and we're actually going to go 5 units up, down, left, and right. That's how we draw circles. So negative 3 zeros right here, that's our center. If the radius is 5 units, let's go 5 units up. Let's go 5 units down. Let's go 5 units to the left. And let's go 5 units to the right. Let's try to connect the dots as circular as we could do it. Oh goodness. Okay, so I mean it looks more like an egg, but that's how you would graph a circle. The kind of problems that you would be expected to know how to do on like an exam look like this. To write, we'll just say write in center radius form. And we'll do 2 of these. Say if we had x squared minus 6x plus y squared plus 10y plus 18 is equal to 0. Well, we want to have perfect squares, right? We want to have x minus something squared, y minus something squared, so we need perfect squares. And if you remember back to talking about quadratic equations, the way that we get perfect squares is we do something called complete the square. So our first step to complete the square was to isolate the variables. It was 4 steps, and we're going to do the same thing here with both x and y. I'm going to say x squared minus 6x plus y squared plus 10y, and we'll just get that 18 out of the way. Second step was we factor out the leading coefficients. Leading coefficient is 1, right? There's no number in front of x squared. It's really just 1, so technically we could factor it out, but it doesn't change the value. Same thing, the leading coefficient of the y squared is 1. So I'll actually show that for my next step. Just so it's a little bit easier to follow along. Now the third step was the most important. This is where we take half, the middle, and then we're going to square it. So set it up. So negative 6 divided by 2 is negative 3. Squared is 9. That's going to go here. Half of 10 is 5. 5 squared is 25. That goes here. And then our fourth step, we just have to balance out our equations. We just can't go adding numbers. We have to balance it. So we added 9 and 25, so we have to subtract them now. So we're going to multiply our new numbers by the front and subtract. Okay, so that means 9 times 1 is 9. That's what we added, so let's subtract it to balance it out. 25 times 1 is 25, so let's subtract it to balance it out. And now it's just a matter of cleaning things up. Remember, this is always going to be a perfect square. It's going to be 1 times x and then half of that middle number. It's really just x minus 3 times x minus 3. It always works like that. Plus 1 times y plus 5 squared. And then we have negative 9 minus 25 plus 18. This comes out to negative 16. Just bring that on the other side. We don't need the ones in front. And there's our center radius form. Now the center, we weren't asked for this, but why not? The center would be 3, negative 5. Remember I told you we could just take the opposites. So it says minus 3, so use 3, plus 5, we'll use negative 5. And our radius, well, if the radius squared is 16, that means that the radius would just be 4 units. Okay, so our last example, what if we had 9x squared plus 9y squared plus 12x minus 18y minus 23 is equal to 0. First step is let's isolate all the x's. Then we'll factor out the leading coefficient. Factor just means divide, right? So we're just dividing each of these by 9. Okay, so now the fun part begins. Let's see how good we are with fractions. We're going to take 4/3, divide it by 2, and then square it. That goes here. Then we'll take negative 2 divided by 2, square it, and that goes here. Well, that's easy. Negative 1 squared is 1. Negative 4/3 divided by 2 is the same thing as 4/3 times 1/2, which is 4 over 6. 4 over 6 is 2/3. 2/3 squared is 2 squared over 3 squared, 4 over 9. And for our final step, what we're going to do is we're going to take our new numbers, multiply by the front, and then subtract it. 4 nines times 9 is 4, so we're going to subtract 4. 1 times 9 is 9, so we're going to subtract 9. So let's clean this up and see what we get. We're going to have 9 times x. Half of 4/3 is 4/6, or 2/3, plus 9 times y minus 1. Then we have negative 4 minus 9 minus 23 is negative 36. Bring the 36 on the other side. Now the 9's aren't supposed to be there. It's supposed to just be x minus h squared plus y minus k squared. So let's just divide everything by 9 to get rid of it. Get x plus 2/3 squared plus y minus 1 squared is equal to 4. There's our center radius form. Now just looking at this, our center would be negative 2/3, comma 1, and our radius would be square root of 4 is 2 units.